Hello team, welcome back to second part of building segmented tree. So the for first video, I'm sure you watched it and you know what we did here. I'm just going back a little bit flashback when I'm writing the code, but this one I'm going to write the code, and the code I'm writing is not pseudocode, it's like really actual code. And then what's the pseudocode means is the fancy name that you can put on the something similar to actual code, but I don't write there like pseudocode, the code that is not real code. I'm writing like actual code. So what we do for programming language, I don't know what's your preferences. People go for Python. I know they love about Python. I'm not Python person. I know how it works, but I do Kotlin here because I do mobile development. I do Kotlin and Swift, but Kotlin is pretty easy understanding language for other people too. So let's do this one. So the language I'm going to write the code for building segmented tree is Kotlin. Wow, look at this giant font. Anyway, let's make this one a little bit smaller. Okay, perfect. So what we do here, remember what we needed segmented tree in the first place. Segmented tree led us to make a query over the array. But this array is really small because I can just write things down for you, but it could be like huge array, and then you want to just make the query a couple of the times over this array. So the segmented tree that we built it here, and the concept was that we just get the summation of these two numbers, and then we have like the summation all of the tree, and then we can go through the tree. And if you need to, for example, from 2 to 4 here, the query you need to from, okay, what's this one here? So I need to query from 2 to 4, then I can come to this tree and I find what is the sum of this range. I will make another video about like how the query works, how is like the policy behind the query, but you need to understand first how tree building, because how can you just make the query the tree is not built yet. So right now I'm going to the code here. So what I will do here, I pick some colors that make it more fun, and then you can understand. I think the color coding is the perfect things, and the human built to understand the pictures and then text. So we're going through this one, and then you can take a screenshot from the things I do, and when you're on the train or something on the bed, or just have a look to that, and then you get the understanding instead of sitting in front of the laptop and just do all this by yourself. Well, that way is much better, but this way is lazy way, which I do most of the time. So okay, let's do this one. You know that we have something called here build, right? That was the build, how the build works. So we are doing the same things here. Firstly, I have an array here, right? This array, the number is array. So I need to have the tree. The tree is data structure, but like end of the day, this tree is the array. And if you can see, for example, how many indexes I have, the 8, 9, 6 is the like 8, 9 here. This is the max I can go, and this is 5. So I can go 2 times of this one will be 10. So the size of the tree, segmented tree, generally the people say put, not people, documentation say put 2 times n, which is n is size of your array, right? But if you want to be more safe side, you can make it 4 instead of 2, 4 times n. There's like the space complexity here, but don't worry, space time is matter. For space you can deal later. So the size of I'm just creating this tree is this one. Some people are really like surprised. Okay, we have a tree like this, and then how can I represent a tree? Technically, end of the day, this is array, but the way that we are indexing this array, make it dash tree. See, this is the connection. You said like this is the how it works. 2 times index 1 is left node, and 2 times index plus 2 is the right node. So that's exactly the thing. For example, if something that you have here is 0, the left will be here, which is 1. Based on that, 2 times 0, 0 plus 1, 1. 2 times 0 plus 2 is 2. So this is the parent node, and this is left, and this is right. So nothing is magical here. So like this, you just have the simple array. What you do, you just like treat it as a tree. But the point is that you need to understand this concept. If you understand this concept, the rest is easy. Don't remember how the code should be work stuff. You just draw the tree, you understand the tree, and can you just write the code based on the tree that you have, any programming language. So that's the problem sometimes with LeetCode. People try to understand code. You need to understand data structure behind the code, and then you can go from the data structure to code. But if you want to go from the code, just like remember memorizing this type of a thing, you need to do like a lot of work, and after 2-3 months just stay away from LeetCode or something like that. Everything wash out from your brain. So you can wash your hand, but don't wash your brain. So let's do this one. Okay, for building tree, firstly I need to have this tree, right? So that tree is work like that. Val is it's like the way that you do in Kotlin, but just take it as a variable. So you just I make that, call it, name it tree, or make it like a little bit more meaningful. I make it segmented tree. I put seg tree, which is a segmented tree. Why do you put words? I don't know. We are a developer. We'll want to make everything short. Why? I don't know. Probably we are lazy. No, there's reason behind that, but I don't want to go through that. So we have a int array. This is the way that you do in Kotlin. And then I can have a size 4 times n. N is the size of this one, right? You don't worry about this one. The main part is that the function that I'm going to write the build, right? So this function is doing this way. Say func, which is function. It's like we call it fun. It's C if you call func. It has a C, but I liked it Kotlin because it's fun. Fun build. And then for the build, exactly the same things that we had. We need start. We needed end here, and we need index. So if you want to memorize this one, say, okay, I will write this code, and then just, okay, you put this one here, you put this one there, it doesn't work. Go to the data structure, look at the data structure, and understand from the data structure and write the code. So firstly, we have a couple of the things here in the based on data structure. We have the first step, we have a left, and we have a left here, and we have a right node here, right? So let's build the left node here. So for building the left node, I just make this color. You just say left, you put val left, what do you call it, like left node. So left node is like that, is recursive. We call this one, we need to build. Let's make it this way. It probably takes a little longer time, but that's easier. So I will say build. Remember the color coding. So what do you need to do? We need to start and end. So for a start, what you can do, you just get the start from here, start here. But for end, see, for end here, this is like left. I'm going to build this one. I have a range from this one. I need to have a range from start to mid, because I want to remember this is the coverage. This is for the left. I'm just covering this one. The right covers this one. There's a time complexity called logarithmic time complexity. I will come back to that one later. I don't want to make you confused with time complexity, but this is related. So I'm breaking this range to a smaller range, right? So technically I divided this range to a smaller range and just going to throw the smaller and come back to that one and to fix it. They call conquer. But don't worry. Technically, we break this one down to a smaller problem, and we fix a smaller problem. We're going all the way up, right? So this one, I need to have breaking this one. What's the range I'm breaking with? Start to mid. So what's the mid here? So I need to calculate mid. I had a formula for mid there. I should stop saying formula. I have how we calculate the mid. So let's put mid here, somewhere here. So let's go for mid. So let's get this one. Perfect. Go mid. While mid equal to same thing. Say start plus end minus start, and then divide by 2. So if you notice, I didn't write the mid here. I just start creating left node and say what I needed here, and then just going to see that I cut it and put it a little bit down. So that's how it works. Most of the code that we see is written the way that from up, like, from top to down. But no, try to write the code. Anytime you need something, you just make the space. So that's why I'm doing this way. Otherwise, I could write the mid and you just will accept, oh, this is the mid should be here. No. Write the code. Anything that you need, just go up and then add it, like here that I do. So I put the mid here, right? And then what else I needed here? Then here I need to have index, right? So the index that we calculated for this guy, for left node, the index is here, right? So sorry, it's a little bit messy here, I know, but you understand. So index is this one, 0 for left index. For left node, the index is 2 times 0 is 0, and then plus 1 is 1. See, we have it here for left node. How can we calculate the index? So for left node, I put the index, and then so I need to have a like left index. I'll put just the calculation here like this, but doesn't work because it's if you put there, it's really confusing. So what I do, I just say, okay, I need the index too. So what I can do, not this way, let's like get this one here. So let's get everything, is nothing left over. So I need to have an index. So what I do, I create the index for us. So the index will be this color, green still, while left index, right? So what was the left index? The left index, it was really easy. It will be like, let's say I fix this one, index. I don't know why always I miss X. So for left index, we do this way. So what was I like say? 2 times index index plus 1, right? So let's say if you fix the color of this one, should be green. And then so this is the left index, right? So we are right now, we are focusing on this piece. We are just doing this piece, right? We're doing this piece. Like technically we are right doing this piece. So we down this left one, right? So I can add some comments too. Just grab this, guys, just going down, and then like here say comment. This is left index. So I'm going down again. So I'm done with this part. So what I need to do, I need to start it with this part. See, this section, which is right node. So if I want to do the right node, for the right node, exactly same deal that we do. To say right node, let's add the comment, say right node. And here is node, right? So for right node, exactly same things. First name, we need to have an index, left index. But if you look at the way that I did here, see, I just cut them, put them around. Technically, based on the data structure, I say I want to calculate left node, right? For doing that, we are doing exactly the same thing. Say build, and then sorry, this is a start here, this is mid that we doing this one, and this is the index that we are passing. Say left index, and here the same thing too. So we need to start with mid, right? So the mid, already we have the mid here. The mid will be, see, we already have somewhere here. Yeah, I cover from here to here. Right now I need to cover here from the mid is already included here. So I start from mid plus 1 to end. So come back here, and then what I do is say here, I say I have a meet here already, say meet plus 1, right? I have a meet plus 1. Then, so what's the end? End is the end because we don't need to do any changes. So for n, I say end. And then what I need to have a right index. See, I missed the x again. I don't know, my brain doesn't like x. So here, coming back here, and for left index, which is technically not left index, is right index. For right index, exactly the same flow we used above. So we're like 2 times index plus 2, right? So that's the right index, and then I will have a right index here, right index. That's like pretty much whole code, but there's a one thing. Imagine this code, not imagine, like really this code going build all the nodes that we have here. It's like recursion, right? So it just coming here, and then but we want to stop, right? We want to stop here. We want to stop here, and then we have the rule for that. If the start equals to end, then we need to just get back. So this is the way that we just stop growing, right? It's like our base case, but you need to have a rule that just going out of that. People call this one whole thing as a decision tree, but technically it's not. I don't like that name. It's not, you're not making decision, you just give choices, right? So this is the situation map. I could call it situation map or graph, you can call it, or situation tree. Let's call this one situation tree. Why? Because this tree shows the situation. People say decision tree, like not people, I'm saying like really actual, like official name is decision tree, but the situation tree is like, for me, is more meaningful and see what shows the situation. So here, how can I get back from here? So that's the rules that I have, the golden rules that I have. So what I can do, I can apply this one. I don't want to this grow forever, right? Because this can grow forever and you get like out of memory issue, so many issues, right? So how can I do this one? So I will make it, I will cut this one here. Sorry, this one is a bit tricky. I cut, perfect. I cut this one here and put it here, right? I need to start fix this T stuff anyway. So why I did this one? Because I could write this code from the beginning. Say, okay, put this rule. If is put this rules, if is a start equal is to end, then you just go back from that, right? But I don't want to do that, and the reason is that because if you write the code here, it's just like, okay, base case, then your brain goes to the situation, you want to formulate this one. Okay, I need to have a base case, I need to have a this one, I need to have a this one. No, you go through the data structure. It's like, okay, here I need to go back, right? The way that you draw the data structure, did you apply the golden rules all the time? No. As when you just reach here, and then that means you cannot like make it like more division, like you cannot go less than this, right? It will be 0 0 0 all the time. So from here you're just going back and going back. So you need to just construct your code based on the thing that you do. But the problem is that for most of the coding that I see, or people like other like tutorials, they just formulate your brain, say, okay, just add this one here, then add this one here, and then add this one here, and then you really try to, when you're just going to like interview situation, or when you're doing competitive programming, your brain try to find the formula, and then when your brain cannot find the formula, you get upset and your brain's stuck. But you need to build the solution. Please remember this one, you need to build the solution, right? You cannot like just jump to like formula probably works for many people, but if you really understand, you need to build it, because the end of the day is the tools, right? The solution is the tools. You need to build the solution based on the tools that you have. Anyway, so come here, let's like clean up here, and then I make this like rule that I have here, like to get out of it, that doesn't let it grow, like the tree growing pretty big. I think I didn't give much space here. Just I put here, and then I make this one red. The reason I'm doing red because red means stop, like don't go more. So if start equal to end, this line is universal in all languages in the world except assembly. So there will start equal to end, then we need to go back. So what we need to go back here, we need to do some action. Firstly, we need to return, but before return here, we need to assign this one. We need to, okay, we get this number, we assign this number. So the first step is that fill up the node. The second step is that just get out, right? Fill here. My handling is horrible, I know. So here, what we do this way. We say, okay, I have a tree, which is this tree here. Well, I call seg tree, seg tree, which is segmented tree. And then here, what is the index we can go? We want to put this in place. What is this place? Is the here is 7, right? So what is this 7? This 7 is the index that we just calculated, right? Say index. So what goes to this one? See, when a start and end is equal to, we can is 0 0, so we can do a start or end. But I'm going from original array here, original array, and then add the index that is currently is there. So what is happening here? We will say array. You can put start or end, up to you, because they're equal. And then this is one part, and the second part is that you need to say return. So that's how it works. Let's make this one clear for you. Let's go from here. See, that's how it works here. Let's clean up here. So yeah, let's clean. So how it works? You just assign to here and then return, which is here. So that's whole code that you need to do for building the segmented tree. I could add like the classes, other stuff, but only we do on this video is that like focusing on this block, building, how the build works. And then you can find the other stuff like other places too. You can just like Google it, Wikipedia, ChatGPT, any tools that you are using. But my purpose here is that how we are building the tree, how we just like translate this, everything's here to code, right? Everything's here goes to the code, to here. So the order is really matter. Unfortunately, we are get used to just having like everything long. No, you need to just build here and go back add, and then just build your tree. Anyway, I will add another 2 videos. One of them I will see how query works here, and another video I will add the code for query, and the last one I just solve one of the LeetCode question based on the segmented tree, and then you can have a good understanding of that. Thank you. See you next video.